Alright, time for another draftphysics.com video presentation. Debatephysics.com also, and that's where these videos will end up eventually, this series of videos. KE is a free energy nut theory, so this is volume 2, and it's just the simplest of the arguments. So it should be understood that Leibniz, the inventor of, the first to propose it as a serious theory, of mv squared being the real definition of energy versus mv, which has a real substance to it. I mean, the m and the v are real features of real properties of things in the universe, where the idea of squaring the velocity has really no physical reality, no correlation to a physical reality. A velocity can't be squared or cubed or any of that. Anyway, he published a year before Newton published, so it was before it was made pretty clear what gravity is, which is a time-dependent force. So it was before the famous 9.8 meters per second. It was before the gravitational constant, whatever, 6 point blah 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 blah. Anyway, big G. So that's the simple argument I'll make here, is 9.8 meters per second, and what that means, okay, is per 1 second. So it should be understood that that's the ratio, 9.8 to 1. So when it's to 1, you can just write 9.8 times something. Now if I change that to a 2, I have to change the number to 19.8. It's 19.6. And frankly, I have to do this math first and turn it into under a 1, and then I can multiply it times other numbers. But I can't really multiply it times other numbers until I fix the fraction. I have to get rid of the fraction. So if it's 1 second, that means you just get rid of the fraction, and it's 9.8 is the force. The force equals that number. And I can multiply that number times things, and like, say, 4 seconds that the thing might be in gravity, and get a number, a real number for how much, what the magnitude of the force is. So the simple, the most obvious, experimental anyway, idea this imposes on the physical reality is this notion that you can drop something 4 times the height, which this is Galileo. So even though Galileo didn't create he didn't calculate, okay, he didn't go as far to calculate this 9.8 number. He certainly was aware of the idea that this is how it functions, okay, that you have this relationship where this is 1 unit of time here and this is 2 units of time here. So even though it's 4 times the distance, the units of time are only 2 to 1, not 1 to 4. Okay. And what you're really doing when you're dropping something is that this actual event is exactly the same as this actual event. And that what's going to happen in this whole time will have to be the same as whatever happens in these. So if you get 9.8 in velocity here, you only travel 4.9, but you get 9.8. And the fact that you only travel 4.9 sort of is a giveaway here, is because all that's going to be added to your distance is 4.9 here. So 4.9 gets added here as the new second piece of time. So the second piece of time, you get 4.9 here in distance in this unit of time, and you only get 4.9 here in this unit of time, except for the stuff you get for free because you're actually traveling 9.8. 9.8 means you travel 9.8, and then you travel 4.9. So you go 3 units of distance in 1 unit of time. Just a fact. That's what velocity means. But you're in the gravity twice as long. Okay, so it's only twice the time, it's only twice the velocity. And the fact is, if you drop this on a spring, and the experiments are essentially proving this, except the liars won't accept the results, and it ends up being twice the weight. It's twice the impact. There's not 4 times the force. You're in the gravity twice as long, you can only collect 2 units of force. 1, 2. 2 of these 9.8s. That's all you get. They're saying you get 4. And you clearly only get 2. So I have, and I will draw it one more time for briefly. So if you have a gravitational body and you do a flyby, well, all that's going to matter is how long you're in this amount of gravity. So here's a distance. They think the distance is all that matters, and you'll be bent by this gravitational body just because of how much distance you traveled. Not going to happen that way. The actual truth, and NASA knows this of course, is that you're bent proportional to your velocity. So the slower you go, the more bent you will be, and the more likely it is you crash, because you'll be in the gravity longer. So the gravity can be understood as just like raindrops falling, and that pushing, and that the push of gravity, okay, is a constant force, and it really just has to do with time. And so if you're in the rain longer, you get wetter. That means you're pushed more. You're in the gravity less time, you get pushed less. It's really that simple. And so we'll leave that as the only argument in this video, and there won't be a reasoned or rational or sensible counter argument. They'll never prove this to be anything I've said here to be incorrect. They'll just say it's incorrect, but they won't demonstrate, they won't draw it, they won't explain it, nothing. And that's physics. Physics is evade the argument and just keep preaching the dogmatic biblical truth. Till the next time and such.